All right, well, let's go ahead and kick things off. Welcome back. Hopefully, welcome back. You were part of part one. If you missed that, welcome to the AASHTO Bike Guide webinar series hosted by the Pedestrian and Bicycle Information Center. My name's Dan Jeline. I'm with the UNC Highway Safety Research Center and delighted to have you back for this discussion where we're going to get into more detail about design principles of high comfort bikeways. In a moment, I'll tell you a little bit more about the what we covered in part one if you weren't here for that. And then we'll get into some introductions right now with our panel. And today you're going to be hearing from Jeremy Charzan joining us back. He's an owner at Tool Design in Silver Spring, Maryland, where he leads the company's multimodal design practice. Jeremy is a licensed engineer in 14 states and has been practicing engineering for more than 26 years. In addition to designing many miles of roadways and bikeways, he served as an author for various design guides and research, including the fifth edition of the AASHTO Bike Guide, the Ohio Multimodal Design Guide, and various NCHRP research reports. So we're very glad to have Jeremy back. We're also welcoming back Hannah Pritchard and Charlotte Claybrook. Hannah is with Minnesota DOT, the pedestrian and bicycle engineer there, and is also the current chair of the AASHTO Technical Committee responsible for the development of the bike manual. Hannah lives in Minneapolis, and so joining us from there. Thanks for being here again, Hannah. And Charlotte Claybrook is the Active Transportation Programs Manager for the Washington State Department of Transportation and was the chair of the NCHRP committee for the AASHTO Bike Guide update and served on the AASHTO Technical Committee on non-motorized transportation throughout the time that the guide was being updated. And so we're glad to have them back. You'll see them again in the discussion period where we've saved some time at the end for Q&A to answer your questions. I wanted to give you a sense of where we are in the series. We are episode 2 of 3. So last time, as you may remember, we talked about sort of historical context and timeline for the development of the bike guide, comparisons of this bike guide versus the previous bike guide, and also introducing some of the safety-based principles that you're going to hear more and more about as we get through some of this material. So today, part 2, what we're going to be talking about are design recommendations for high comfort bikeway facilities and shared core design elements. Intersections will be addressed in this webinar as well. We're going to be talking about things like the basis of design elements like sight distance and design speed, design considerations for protected bike lanes, side paths, and shared use paths, and also bicycle boulevard design. If you're interested in topics like conventional bike facilities, other prevalent bike infrastructure, wayfinding, end-of-trip facilities, we're going to be covering that in part 3. So that's just to say that if you have questions today about some topics that we know we're going to get into detail on in part 3, we may hold those until that webinar just to make sure that we have enough time to handle the content that's going to be talked about more today. We are archiving all of the webinars from this series on our website. If you go to pedbikeinfo.org/webinars, you'll find the recording and the material from part 1. The slide 2 slides are already up, and we'll be recording this one, or recording it now, and that should be up by tomorrow. So if you miss anything or want to refer back, it's there for you. I also wanted to mention that after the 3-part series, we're planning to do a couple of deep dive sessions where we spend a little extra time talking about topics that seem like they generated a lot of interest and more questions than we had time for in the main series. So in part 3, if you're able to come back for that one, we're going to be doing some maybe interactive polling during that session to help ask you to help us decide what should we use those sessions for, what should we focus on in more detail. We'll also be gleaning that from the questions you submit today, some of the discussion we get going. So just know that those are coming, and we'll be sharing more detail about them a bit later. I wanted to put a quick plug in for a project that we're working on here at PBIC, not directly related to this series, but in some ways it is. We are trying to create a comprehensive database of cost information for pedestrian and bicycle and other complete streets type projects. And so we're looking to you in the community, practitioners, advocates, and others who are working on these projects to help contribute your cost data to this tool. We want this to be fairly large, all-encompassing, different regions of the country, urban, rural, and we've created a survey. QR code is there for you, and I'll share the link in a moment, where you can go and take a few minutes and just drop in some of your cost detail into that. It would really help us create a really robust tool that can, again, be used by you all, hopefully, in projects you're working on, cost estimating, things like that, planning purposes. So please go there. Let us know if you have questions. We appreciate any input you can provide. I just want to say one bit of housekeeping. You can submit questions anytime. We are archiving the webinars, as I mentioned. You'll get an email tomorrow with information about how to report professional development hours, how to get a certificate for the webinar by completing a post-webinar survey, and again, links and things that you'll need to get to previous episodes and then registering for the upcoming episode if you haven't already. That's all that I have today. And Jeremy, I think I'm ready to turn it over to you to take us through some of the part two material. And again, folks, just send in your questions whenever you have them, and we'll be monitoring those. So thanks, Jeremy. I've got your slides up.
All right. Thanks, Dan. Thanks for having me back. Looking forward to discussing high comfort bikeway design. Just as a quick refresher, this slide shows the comparison of the 2012 guide to the new 2024 guide. In the first webinar, we did get through chapters 1 through 4, so introduction, safety, planning, and facility selection. And so today we're going to stay focused on chapters 5 through 8, elements of design, a brand new chapter, shared use paths, separated bike lanes and side paths, and then bicycle boulevards. And both of those similarly are new chapters in the guide. Chapter 5 is probably one of the most important chapters in the document. This is the place where core calculations are provided, sight distances, intersection design principles, etc. And our thinking, again, from thinking back to the first webinar, we discussed that one of the goals of this update of the guide was to make this more functional for practitioners. And as we started to look at content for various facility types, we started to see that there were a number of things that were consistent across multiple facility types. And so rather than duplicating that information chapter after chapter, instead the decision was made to consolidate that information into this elements of design chapter. So this is sort of going to be your go-to chapter for finding some of those core pieces, and then you'd go to the individual facility types to get more design information on those individual facilities. So like I said, sight distance is one of the important things that's discussed in this chapter. So stopping sight distance for bicyclists is one of those foundational design things that we need to be looking at. And so it's something that's presented right up front. It is important to note that we present information for both expected and unexpected stopping. So there are locations where bicyclists expect that there are going to be conflicts, and in those situations, a quicker reaction time can be more appropriate, 1.5 seconds. By comparison, locations where conflicts are less expected, that's a location where that perception reaction time is likely to be a little bit longer. And so 2.5 seconds is what's going to be appropriate for those locations. As I mentioned in the first webinar, we did provide all the formulas that you need if you want to do the math yourself. But this is another one of those instances where we provided the tables to serve as sort of a lookup table so that you don't have to enter all that information, and keep your calculator in your top desk drawer. So what's shown here is that bicyclists stopping sight distance for 1.5 and 2.5 seconds of reaction time based on the design speed for the bicyclist, as well as the relative grade of the bicycle facility. So that way you don't have to do all the math yourself. Another important thing that we discuss in this chapter is this recognition that sometimes the right of way of who has the right of way at an intersection varies depending on who will arrive at that location first. And this sort of aligns with the rules of the road principles for pedestrians as well, that a pedestrian in a crosswalk has the right of way, but similarly a pedestrian can't suddenly leave the curb at a point where motorists are too close to be able to stop. So there are instances where right of way changes based on conditions, and that same sort of approach applies for motor vehicles. the last bullet on here also reinforces that sometimes users who have the right of way will also yield that right of way to another user. I encounter this all the time on my bike ride into the office, that the approaching motor vehicle actually has the right of way, but they decide to slow and stop and wave me through. And, the guide recognizes that that's the practical reality of some situations as well. So I'm not going to walk through all of the case studies that we discuss in chapter 5, but I will touch on some of the important ones just so that you're aware of them. Sight distance case S is for a right turning motorist turning across either a separated bike lane or a side path. And this is a really unique sight distance, unlike any of the others that we present in the guide. And it's because it's a unique situation that you have two vehicles moving in the same direction at different speeds. And there's not really a comparable sight distance to that you'd find in something like the Green Book. So essentially, your sight distance triangle almost is in constant motion. And so the recommendations kind of reflect that approach. And so instead of simply a sight distance triangle, we introduce the concept of approach clear space, that the area approaching an intersection needs to be free of obstructions so that both the bicyclist and the motorist can see one another and react accordingly based on who will have the right of way. And again, unlike some other sight distances where you're using a sort of static speed, this approach clear space is based on how quickly the motor vehicle by design would be going around the intersection corner. That then is tied to what is the effective turning radius at that location. That will inform what speed they can navigate that at, and that will inform the decision of how much approach clear space is needed. I also want to note that approach clear space is measured from the point of curvature of the effective turning radius of the motorist. So while illustrated here in these images, the point of curvature of that effective turning radius is actually the constructed point of curvature of the curb line. There may be situations in your intersection design where the PC of that effective turning radius isn't necessarily the physically constructed radius. So please be aware of that when you're assessing approach clear space. So just as a quick example, if you had a corner with an 18-foot constructed corner radius or effective turning radius, that implies that the motor vehicle would navigate that turn at around 10 miles an hour, and therefore 40 feet of approach clear space would be needed for those users to be able to see and respond to one another. Sight distance case U1 is another important one that deals with the sight distance of a motor vehicle on a stop controlled approach, being able to see bicyclists on a side path or separated bike lane that is on an uncontrolled approach. And so in these situations, there should be enough time for the motor vehicle to see those approaching bicyclists and navigate through that intersection without the bicyclist having to stop. But again, the guide recognizes that that's not always going to be practical. And so at a minimum, the provision of stopping sight distance for the bicyclist is necessary as our minimum value for this. It's also important to note that there's a variation of this that we discuss in chapter 7. These particular figures aren't included in the guide, but they're representative of the text that is discussed in that document. This recognition that per the vehicular laws, a motor vehicle approaching an intersection should stop at the stop bar, look for pedestrians. If there are none, they can move forward into the crosswalk to look for approaching motor vehicle traffic. And in this case, they're looking for approaching bicyclist traffic. If they see that there is none, they may be permitted to move forward into the bike lane where they can better see approaching motor vehicle traffic. So that's just an important variation to be aware of, particularly in highly urbanized areas where removing all the parking on a block face simply to provide one long continuous sight distance might not be practical or politically acceptable. Another important consideration discussed in this chapter is how to make shared use paths yield controlled instead of stop controlled, and sort of this recognition that the regular installation of stop signs on shared use paths generally is not fully complied with, and that typically occurs when there is adequate sight distance for that intersection to function in a yield controlled condition. And so the sight distance is shown here. If we have adequate sight distance, then that shared use path can function in a yield controlled condition. And instead of installing a stop sign, a yield sign would be more appropriate. Nothing substantively changed for sight distances for horizontal curves on shared use paths, but I just highlight it because it is an important thing to be thinking about as we're laying out the design of shared use paths and thinking about where landscaping is going to be located or how much clear area is needed adjacent to a shared use path. While it may be appropriate on long straight stretches to have a little less clearance from that vegetation, as we have points of curvature, it's necessary to ensure that we're maintaining those clear lines of sight so that a bicyclist, if they see something in the path, has enough time to stop or at least react to that object or surface obstruction, etc., that might be located in the path. And then chapter 5 is where we also set the stage for intersection design objectives or principles that should be applied at any intersection. And those are really important, minimizing exposure to the conflict, so keeping conflicts as short as possible, reducing the speeds of users at the conflict points, making sure that we're communicating who has the right of way and that we have adequate sight distances for those users to see and respond to one another. Intersections are also the locations where transitions from one facility type to another are most likely to occur. So clearly thinking through what those transitions will look like and that they align with those principles that we discussed in the planning chapter, that they be safe, comfortable, and intuitive as well as legible, that there should be clear wayfinding on how to navigate those transitions. And lastly, but certainly importantly, ensuring that the design of those intersections accommodates the needs of people with disabilities. Another important thing to be thinking about is motorist yielding and how many crossing opportunities a crossing bicyclist has at an intersection. And so one thing that we know is that on roads that are low speed with few lanes, motorist yielding is much higher than locations with multiple lanes and higher motor vehicle speeds. And that where we have those more high speed, high volume locations, the need for additional countermeasures or more crossing opportunities is going to be essential, since we know the motorist yielding is likely to be lower. So one thing the guide stresses is that generally speaking, we want to have at least 60 to 120 crossing opportunities for a bicyclist per hour. That'd be the sort of natural gaps in traffic in order to be able to cross, and that more than 120 would be preferable. This idea that if a bicyclist has to wait more than 30 seconds at an intersection, they're more likely to make risky behaviors or accept narrower gaps. But through design, we want to strive to avoid that sort of issue. So the idea that we present is this series of tiered approaches of countermeasures that may be appropriate based on the number of lanes, the motor vehicle speeds, and the motor vehicle volumes. And if this chart looks familiar to you, I would say we sort of borrowed from the approach that Federal Highways took in the pedestrian steps guide, the sort of hierarchy of treatments that would be appropriate based on the conditions of the roadway that you're encountering. So in those less complex environments, simply signing and markings might be appropriate, whereas in our most complex locations, pedestrian hybrid beacons, signalization, or grade separation might be the appropriate tier of approach for those countermeasures. Also in this chapter, we walk through a variety of treatments to help address some of these issues. So specifically geometric treatments in order to address those intersection design principles. So certainly median refuge islands and centerline hardening are one of those treatments. The refuges sort of serve both as a refuge for crossing users as well as a hardening of that center line. In some situations, that will serve as a chicane or horizontal geometry changes. But that's an important intersection treatment that we can employ to help address comfort and safety. Another one is the use of mountable truck aprons. You know, we talked about from a sight distance perspective for side paths and separated bike lanes, the effective turning radius of the corner for passenger vehicles is sort of the controlling criteria. But we can't overlook the fact that we also need to accommodate larger control vehicles at many intersections. And so the use of a mountable truck apron can control the speeds of those passenger vehicles using the smaller radius while still accommodating the larger turning characteristics of a vehicle. The AASHTO Bike Guide does illustrate two approaches here. One is showing that as more of a physical construction out of concrete, while also recognizing that we have the ability to use more temporary treatments or retrofit type treatments to accommodate these style designs. And these aren't pie in the sky ideas. They are in deployment around the US. I think this one's San Francisco, and you can see the gored out area is a mountable truck apron. Here's that same location from the opposite angle. In this particular instance, the designer used a vertical curb, but many others use sloping curbs or mountable curbs. One thing I wanted to highlight about this design is, other than the vertical curb, this idea of tapering off the mountable apron on the downstream side of the apron might be a design feature that communities in cold climates that get snow might want to consider. And this idea of tapering that off means that as a plow drives off the apron, they're not depositing snow on the downside of the apron. And that by tapering it off, it makes that plowing a little more efficient while also still serving its purpose of controlling effective turning radii. But like I said, we do see these around the US. This one's Pittsburgh, Pennsylvania, in a particular location with the protected intersection. So really deploying the treatments that are in the bike guide in the way that they were envisioned. And certainly they can also be done out of quick build materials. This one's in Silver Spring, Maryland, using those sort of segmental treatments used for quick build roundabouts, but repurposing them as mountable aprons. So a lot of ways of accomplishing this goal, regardless of the type of project that we're deploying them in. Raised crosswalks or crossings is another important design treatment, particularly across side streets, but can also serve the purpose of creating more crossing opportunities and slowing vehicular traffic at shared use path crossings. And the idea being that by introducing this treatment, it is both a vertical traffic calming element as well as a way of elevating the crossing users so that they're more visible to approaching motor vehicles. Another important consideration that's sort of tied to the design of raised crossing is, again, thinking about the needs of people with disabilities. If we're raising things up and creating surfaces that are flush between the bikeway and the sidewalk, that might be one of those situations where directional indicators might be deployed. And I'll talk a little more about them here in a few more slides. And then chapter 5 also discusses the design of bike ramps, since that is applicable to multiple facility types. It shows a number of different configurations, recognizing that the geometry and the placement of bike ramps does vary and can vary significantly from project type to project type. One thing that it does note is the use of directional indicators or detectable warning surfaces. They're both labeled as optional. One thing I want to stress about that is that sort of is an artifact of the AASHTO Bike Guide approval process, that we have multiple states that needed to vote on this and different perspectives from different agencies on how to address accessibility. So some agencies are using both of these treatments, some are using one or the other. A very few of them are using no treatments, but I would stress that doing nothing can create issues for people with vision disabilities, and that at least one of those treatments should be encouraged in your designs. The use of directional indicators is another important consideration when we have sidewalk level bikeway design and need to separate users into separate spaces. And so the recommendation in the bike guide is that if we are using these treatments, that they should not be located directly on the interface at the edge of the bikeway. Rather, they should be located at least 1 foot off from the edge of the bikeway, with this recognition that some pedestrians will walk upon the directional indicators, and placing them on that boundary would mean that they would be overhanging into the bikeway design. So again, at least a 1 foot off, but also should, be placed so that they avoid things like utilities and other obstructions. So sometimes it's appropriate that they're even further away from the edge of the bikeway. The other thing to consider is that the direction from which a pedestrian is approaching will affect how wide these treatments should be. So if pedestrians are only encountering them in a parallel manner, they only need to be 1 foot wide. But if pedestrians might encounter them in a perpendicular manner, really they should be at least 2 feet wide. And if I just go back a couple slides here, this is one of those graphical issues in the bike guide that really this directional indicator here, since pedestrians might encounter it in a perpendicular manner, really that one should probably be illustrated as 2 feet wide, as opposed to this one where they're really only encountering it in a parallel manner. And then at the end of chapter 5, we just highlight signing and markings. So we do talk about the signs identified in the MUTCD, as well as those that are experimental. So unfortunately, in the 11th edition of the MUTCD, they did not include the turning vehicles stop or yield for bikes and peds sign. So if you are trying to use a sign like that, the guide does flag that that's experimental, though you can use an all word sign that doesn't require that request to experiment. And so for signs like this, we do give you some ideas of where signs like that might be appropriate. So for example, locations where turning motor vehicle traffic exceeds 50 vehicles per hour might be a situation where you want to highlight that potential conflict with these types of signs. And then also the placement of pavement markings. All of this aligns with the content in the updated MUTCD. So with bike conflict markings, those are, green conflict markings can supplement the lane extension lines. It is recommended if you're doing those sorts of green conflict markings that you try to align the bars with the wheel path of the motor vehicles. Same sort of design principle that you use for high visibility crosswalks, just to help address both the durability of those markings as well as the visibility of them from the perspective of the motor vehicles. I also showed the two-stage turn boxes in here. It's important to note that the 11th edition of the MUTCD does now allow the use of two-stage turn boxes at unsignalized intersections. So that differs from the previous interim approvals. So we have a little more flexibility on where that type of treatment can be used. Moving on to chapter 6, that's where we discuss the design of shared use paths. A lot of the content in this chapter is somewhat similar to the content from the 2012 edition, but there are a few important differences that you should be aware of. Within this chapter, similar to the other design ranges used for facilities, we give you a range of design values for width that should be considered, and that this is tied to the anticipated volumes of your shared use path in the shared use path's peak period. And so while that peak period might not be the same peak period as your AM/PM adjacent roadway, your peak period for a shared use path might be that beautiful Sunday morning where everybody wants to get out onto the path and use it at the same time in the morning. So sort of designing for those types of higher volume conditions is really what the guidance is trying to drive home here. Also, while in the past, many agencies have sort of defaulted to what was the minimum 10-foot wide width for shared use paths, one thing this chapter tries to stress is that we should be thinking about the number of operational lanes that exist on a path, and that particularly if we're trying to accommodate social cycling or allowing bicyclists of different speeds to pass one another, that a 10-foot width really does not provide 3 lanes of width, whereas an 11-foot wide width will accommodate more of that social cycling and passing. And so as a starting point on our projects, we're really trying to start at least an 11-foot width to accommodate some of that natural behavior. All of our recommendations in terms of width are tied to FHWA shared use path level of service. So that is a spreadsheet you can download from Federal Highways site, and based on your split of users can identify that shared use path level of service. Again, we suggest striving for at least bicycle shared use path level of service C, but giving you all the tools to make those decisions on your projects. Thinking about shared use path level of service is also an important consideration when thinking about not just the width, but thinking about in our most high volume shared use paths, is it really more appropriate to place bicyclists and pedestrians in separate spaces? And so we present a number of options to be considered when thinking about those higher volume paths. So option one, illustrated in that upper right image, is your common shared use path where everything is shared space. Option number two is where the spaces are sort of more suggestive. I've seen this in, very wide shared use paths in places like Minneapolis, where you have old rail corridors, you have a significant amount of space, but you're just designating the space for pedestrians and bicyclists using pavement markings, meaning it's more suggestive. It's fully expected that pedestrians will sort of spill over into the bicyclist area and vice versa, but it helps to put users into sort of more dedicated places. And then option three is essentially, instead of providing a shared use path, that instead you provide a separated bike lane and an adjacent pedestrian only space. So really tied to the volume of users, the width that we have available to us, and trying to accommodate these more comfortable shared use path level of service. Another important consideration with any of these is to be thinking about the accessibility piece. And so the placement of detectable warnings at intersections is going to be different if you're designing it as a shared use path versus a separated bike lane with an adjacent sidewalk. We also cover the, shared use path adjacent designs, the shoulder of it, avoiding hazards and the placement of fencing and barriers where we have drop-offs or water hazards, those sorts of things. So all of that is presented in this chapter. It's consistent with past additions, but noting that the shy distances from objects align with the content presented in the earlier chapters. And nothing has substantively changed with regards to horizontal curvature of shared use paths, though it is important to remember that also upfront in the guide, we do highlight that minimum turning radius for the adult bicyclist is 5 feet, or 10 to 15 is recommended, and that might not be reflective of what you see in the table for shared use paths. And part of that is we're saying minimum turning radius for a bicyclist at, say, an intersection is going to be different than on a shared use path where you're maintaining your speed, maintaining your center of gravity over the bicycle, and simply leaning with your bike. At intersections, you have the ability to kind of alter your center of gravity when turning. So that's why there's a little disconnect in the minimum radii for a shared use path for some of the other guidance that you'll see in the guide. And then shared use path intersections is an important one to be thinking of. As I said before, the routine installation of stop signs on shared use paths should be avoided. So really driving home the point that if we have the site distances to accommodate yielding conditions, use of a yield sign can be more appropriate while still giving you the option and flexibility to use stop signs where those conditions are actually appropriate. Also wanted to strive to recognize that there are situations where we have high volume shared use paths that cross lower volume roadways. And in those situations, it can certainly be more appropriate to allow the shared use path to function as the uncontrolled leg of the intersection, while the adjacent roadway functions as the stop controlled approach. And the guide does speak to that type of design. And then the last thing I wanted to stress in the design of shared use paths is this idea that the routine installation of bollards should be avoided, that essentially bollards should be the treatment of last resort, and that we should try all of the things on this list before resorting to the installation of bollards. So signing no motor vehicles, using different materials to better convey to a motorist that this isn't their space to turn into, use of a raised center island like that shown on the figure here can be appropriate. Certainly, this is one of those instances where if you have existing issues of vehicular encroachment, a little bit of enforcement could go a long way. And then lastly, considering the use of flexible treatments rather than a rigid bollard. If you do get to the point where you've identified that a bollard absolutely is necessary, it must be reflective, it must still accommodate the widths discussed in PROAG, and you also need to have markings to guide bicyclists around that treatment. The reason we stress this is because bollards really do serve a safety risk to bicyclists, particularly those traveling in single file who might not see that approaching bollard. And there have been a number of issues of bicyclists striking bollards and having lifelong injuries as a result of that. Moving on to chapter 7. Chapter 7 is also a little unique in that it discusses the design of separated bike lanes, but also mentions side paths because the geometry of a side path, particularly at intersections, really follows a lot of the same design principles as a separated bike lane. So if you're looking for how wide should a side path be, you'll look to chapter 6 to get that information, and then how to design some of those intersections might be covered in chapter 7. So right up front, we established the design principles of a separated bike lane and the different zones associated with that. So not only do you have to have your bike lane zone, but you also need to have a buffer from the adjacent roadway, as well as some sort of detectable buffer from the adjacent sidewalk. We do discuss the various elevations that bikeways should be constructed at. We do not provide any sort of hierarchy in the guide of which is preferred. I can tell you personally, I'm striving for more intermediate level separated bike lanes due to the benefits they have in terms of the practical grading of a project, as well as better addressing pedestrian detectability, particularly in lieu of a sidewalk level design. Intermediate level bikeways will also have the benefit of allowing transitions to things like adjacent bike parking to be a little more practical if we're able to use things like a mountable curb. This is going to become more and more important as we have heavier bicycles like cargo bikes and electric bikes, that lifting up a vertical curb is not very easy. And so being able to make those transitions more intuitive should be part of our thoughtful design process. But we certainly have the flexibility to install separated bike lanes at street level. Pretty much any retrofit project that's in paint and posts is going to be remaining at street level, as well as the ability to install a sidewalk level separated bike lane. I've said it before and I'll say it again. It's really important to be thinking about the pedestrian accessibility piece on this. And so having a reliably detectable buffer, preferably a non-walkable buffer, can help to separate the sidewalk space from the adjacent bicyclist space. We really tried to explain the trade-offs associated with different design decisions and stressing that a one-way separated bike lane located on the right side of a roadway tends to integrate better into natural expected roadway design and user behavior. So that's going to be preferred over the use of a two-way separated bike lane. There's more intuitiveness and makes the connections to adjacent bike facilities a little easier, but also recognizing that one way isn't always possible. And so sometimes two way is the right design. You do get to save a little bit of space because you only have one street buffer instead of two. But two-way facilities are going to complicate intersection operations and may require new signal equipment if nothing is present for that sort of counterflow direction of travel. So in terms of widths of a separated bike lane, similar to what we saw in the shared use path, it's tied to the anticipated volumes of users. But interestingly, it's also tied to what is located along that bicycle facility. And so if we have a facility that's located between two vertical curbs, then the shy distance from that vertical curb is part of the consideration of how much width curb face to curb face is needed. By comparison, if we have bikeways that are along mountable curbs or along no curb at all, there's none of that shy distance consideration. And so more of the paved space is actually functional space. So that's why there's this variation in values based on what's located along that facility. I also want to stress that designing at the lowest end of this top row really doesn't accommodate much passing. So it accommodates sort of limited passing, and certainly designing at the practical minimum will not accommodate any passing at all. So we really need to be thinking about that as we're approaching these designs and ensuring that the natural operation that we're expecting can be accommodated through the design. Two ways, very similar approach. What's located along it generates how much width is needed, as well as the volumes. In all of these cases, though, passing will be accommodated because by its nature, it's a two-way facility. So you have enough width for one user to pass the other if they have to cross into the oncoming direction of travel. And then I won't get into each one of these street buffer types, but within the guide, we do discuss the benefits, design considerations, and associated challenges with all of these different types of facilities. So raised medians and precast curbs, concrete barriers, vehicular parking alone, planters, as well as flexible or rigid posts. So each one of those is part of your project design decisions, and we give you the tools to sort of assess the pros and cons of each. And then I think this is the last time I'll say this. Thinking about the sidewalk buffer, it's just essential that we're thinking about that accessibility piece. So thinking about accessibility, but also thinking about what other design elements do we desire in our street environment? Street trees is a great thing to include for shade along both the sidewalk and the bikeway, and the sidewalk buffer zone can be an ideal location for some of those treatments, amenities, and appurtenances. And then because separated bike lanes represent a more substantive change to design, we also tried to drive home the various drainage design options that we have to convey stormwater across or into separated bike lanes. So on the left, there's a variety of different strategies that are illustrated. There's probably a few more than that that we've deployed on projects, but sort of reinforcing that we have a lot of flexibility on where we're conveying that water to and where we want to locate the drainage structures based on each individual site condition. And then I'll highlight here on the right side of the image that separated bike lanes can also be used to help incorporate things like green street infrastructure, stormwater infiltration, things of that nature. And that sort of the space under the bikeway can also be used for storage capacity for some of that underground storage. And then digging into intersections, we strive to align ourselves with these design principles mentioned here, minimizing exposure, reducing speeds, transitions, right-of-way, sight distance, and ensuring that motor vehicle entry into the bikeway is restricted. And that by and large, a protected intersection design is what's going to be preferred for separated bike lanes as well as for side paths. And so illustrated here, you can see that that geometry and the elements of a protected intersection are kind of consistent from a separated bike lane to a side path style design. The one thing I'll mention about protected intersections is they always have some sort of corner island treatment, and then you should strive for a motorist yielding zone of between 6 and 16.5 feet. That research has shown that at both controlled and uncontrolled protected intersections, that 6 to 16.5 is sort of the sweet spot where motorist yielding tends to be the highest. I will note that guidance from NACTO differs a little bit from this, but fairly well aligns. I believe it says 10-foot minimum and doesn't give a maximum value. But again, if we're looking at all these design guides as a whole, they're saying fairly consistent things. And then also noting that if we're talking about things like protected intersections, particularly to the public, that showing graphics that are more illustrative like this, three-dimensional, are going to be more effective at conveying the design elements and help the public to understand how this might look in their community. So again, how that looks for separated bike lanes as well as side paths. I won't walk through all of the design elements of the protected intersection, but the one to stress here is the corner island, and that's the thing that's going to slow the turning vehicles, but it's also the thing that can create opportunities for a forward queuing area. So if we look at the protected intersection here, a bicyclist can sort of tuck in behind that corner island, and when this direction north-south gets green, they already have a head start because of that forward queuing area. But we recognize that we can't always do protected intersections. So the guide does discuss transitioning a separated bike lane to either a mixing zone or a more conventional pocket style bike lane. We do stress that the lengths of these lanes should be minimized, that again, aligning with that principle of controlling motor vehicle speeds at the conflicts, that the closer the motorist is to the intersection, the likelihood that they'll already be slowing down to navigate the turn. So that's really stressed in the design recommendations. I'd further point you to NCHRP 1125, which was released after the release of the AASHTO Bike Guide, which does provide a framework for intersection design treatment selection that prioritizes protected intersection and separated bike lane design before considering mixing zones and pocket bike lanes. Some of those same design principles can also be applied to driveways, and that, low volume driveways, perhaps those can be addressed with simply marking the conflict area, but higher volume driveways either should follow the intersection design principles or incorporate some of those design elements to control the speeds of motor vehicles entering and exiting those driveway locations. So illustrated here is using a raised crossing to further control the entering speed of a motor vehicle and draw attention to the presence of crossing pedestrians and bicyclists. I'll also note that we can maintain facility elevation across driveways, particularly lower volume driveways. So what's illustrated here is a design treatment. I think this is actually in Vancouver, but the detail in the bottom right is from the city of Austin's interim standard details, illustrating that we can extend mountable curbs across driveways, which can still be mounted by motor vehicles, doesn't have to change the elevation of the bikeway, and also provides detectability for pedestrians going across a driveway, something that we don't typically see in a standard driveway apron. Separated bike lanes also present some unique challenges or at least design considerations that we need to be thinking through. And one of them is the placement and design of accessible parking spaces along a separated bike lane. I will note that while AASHTO was released after the release of PROAG, not all of the figures got updated to align with the design guidance of PROAG. So what's shown here on the slide is what was included in the bike guide, but to align ourselves with the guidance of PROAG, really we need to alter that to provide that 13 by 24 foot long space that PROAG calls out. We're no longer demarcating that accessible aisle from past drafts. And so really this is the design approach we should be using for uh, accessible parking space adjacent to a separated bike lane. Transit stops also present some unique challenges in that we essentially need to cross pedestrians to a separate boarding island. We typically call these floating bus stops. And so it has the same crossing principles as any pedestrian crossing. The bicycle lane is a vehicular lane, so you need curb ramps and detectable warning surfaces to indicate where those crossings need to occur. We still need all the accessible design treatments on the floating bus stop itself, at least a minimum 5 by 8 boarding and a lighting area. If shelters are provided, we still need to have all the accessible route widths and connections from that shelter to that boarding and a lighting area. But there's lots of different considerations for the design of this and the placement of them. So alternative one here is showing integrating the access to the floating bus stop into an intersection. I can tell you from work with people with vision disabilities, they really appreciate that style design, particularly at signalized intersections, so they can gain the benefit of the signal to cross the bike lane, but recognizing there's lots of retrofit style designs and placement that might not be able to accommodate that. The bike guide does speak to that. And again, these aren't pie in the sky ideas. We see these being constructed around the country. This again is city of Austin. So this is it in construction. And I show this because you can better see the mountable or sloping curbs that they're using along their bikeway. And that it's really only at the pedestrian crossing that those surfaces are flush. So you maintain that detectability and have those elements to guide pedestrians out to the floating bus stop. And then lastly, with regard to separated bike lanes, those transitions are going to be super important. That by and large, we strive to make transitions on the far side of intersections while also sometimes creating options where you can transition near side. So the example on the left, the preference would be for the bikes who are arriving on green to at least get through the intersection and then they can merge once they get a gap in traffic, though giving them the option if they arrive on red to enter into a bike box and claim their position in the lane since they're entering a shared lane environment. Also recognizing that two-way facilities do present a little more unique challenges when it comes to transition, and providing options should really be thought through. That if you don't provide all the potential routes that bicyclists might take, they might do what was unexpected, like cross in the pedestrian crosswalk because that's the direction that has the walk indication at their time of arrival. So really think through the transitions on this and make them as clear and intuitive as possible. And then the last thing in this chapter that I'll highlight is this is also where we discuss the design of raised bike lanes. That a raised bike lane is sort of a subset of a separated bike lane. It doesn't have all the same design elements. It doesn't have a wide street buffer, but it does raise that bicyclist up and separate them physically from the adjacent motor vehicle traffic. There are different widths associated with them. So you'll see that the widths here are a little bit wider than conventional bike lanes, part of that is because most bicyclists aren't going to be comfortable riding right out at that edge of curb line adjacent to the motor vehicles, and they're naturally going to shy away from that. So the widths reflect that. And then the last chapter we'll discuss is bike boulevards, and that bike boulevards are probably one of the easiest design facilities to develop, and they're the smallest capital investment and can still accommodate the needs of people of all ages and abilities and provide them with that low stress bike network and routing to get to and from destinations. But it's important to note that a bike boulevard is not simply a shared lane environment. It has to be a shared lane environment on a low speed, low volume street with other characteristics that help to control those vehicular speeds, as well as bicyclist wayfinding. So in terms of principles, we're managing the speeds, we're providing them with safe crossings, particularly at complex intersection locations, and that those crossings are safe and convenient. So again, those crossing opportunities we discussed apply to a bike boulevard that might be crossing a collector or an arterial, that if that's too stressful of a location, then it's not going to function as a bike boulevard because people won't be able to use it to continue along their route. Um, Also, in terms of volumes and speeds, really we're looking for 1,000 to 2,000 ADT and 15 to 20 miles an hour, though we do allow for up to 3,000 ADT and 25 miles an hour. But I'll stress that at those higher volumes, 3,000 ADT, a person riding on that bike boulevard for a 10-minute trip would get passed 21 times by a motorist on that 10-minute trip. So that's the trade-off with higher volumes, is that the more volume, the more potential conflicts between those users. And that's why we really stress that the volume should be as low as possible. In terms of speed management, we give you a lot of different tools to consider: horizontal deflection, placement of median, chicanes, etc. Those are great tools, as well as vertical deflection, speed humps and lumps and speed tables. All of those are mentioned in the guide. In terms of controlling volumes, if your street already is at that low volume threshold, there's not really any of this traffic diversion that you need to consider. But on streets that have volumes that are a little higher than desired, it might be appropriate to include traffic diversion to get those volumes lower, that essentially you pull some of those through movements or cut through traffic off of these roads and move them to adjacent roads, while still allowing the bicyclists to proceed along those routes. And again, these are being deployed throughout the country. I think this one's from the Twin Cities. Again, about the bollards, though, watch out for placement of bollards. And then others, like at intersections, you can consider things like a forced turn that allows bicyclists to have two directions of travel, while motor vehicles are forced to make turns at those intersections. And again, these are not just pie in the sky ideas. These are things that are being deployed on the street networks all across the US. I think this one's in Madison, Wisconsin. And then we also have to recognize that transitions at intersections really need to be thought through, and that some of our best bike boulevards don't actually occur at four-way intersections. Sometimes they are those offset intersections because, naturally speaking, they don't have as much vehicular movement because they aren't through movements for the motor vehicles. But if we're trying to accommodate that for a bicycle boulevard, we do need to provide that low stress connectivity from one leg to the other. And that can be with dedicated separated bike lanes, or in some cases, use of more conventional bicycle infrastructure. So that's all I wanted to cover today. Like Dan said, we will cover a lot more in the next webinar for some of the other facility types, but curious to hear what questions you have. One thing I'll note is AASHTO did give us a 10% discount code for anybody attending any of our webinars or trainings. So I'll just leave this up on the slide just for a few more minutes or moments so that you can take a screen capture of that or grab your cell phone and snap a photo of that if you want to claim your 10% discount on the AASHTO bike guide.
Great.
Dan, I'll bet you have a lot of questions.
We got a lot. You were right about that. So on the discount code note, a few questions came in, and I've been sharing that out. Um, there's a link that I've been providing out to the AASHTO store where you can buy this. But in addition to being right here on the screen, if you forget to take a picture of it, if you go back to the part one recording, you can find it in there. We'll post this recording too tomorrow, so you'll be able to get it. Email us if you can't find it. I kind of wanted to start back at the top and see maybe some of the questions that came in at the beginning. We'll kind of move chronologically, I think, through it. All the content on the site triangles that you shared, Jeremy, what kind of assumptions go into those site triangles? So people were asking about, maybe older drivers might have different ability to, turn heads and have the same visibility. Do you know sort of what assumptions are baked into those site triangles that were used for the guide?
Yeah, I do. Um, so at most of the conventional site triangles, it's the same design approach used in developing site triangles in the AASHTO Green Book. So the placement of the vehicles is consistent with all those approaches, how far set back from the adjacent travel lanes and roadway, all of that's consistent. The only one that's a little unique is that site distance case S, or the approach clear space one. And
Mhm.
the the design considerations that went into that were the turning speed of the motor vehicle, a recognition from the research that bicyclists tend to slow approaching intersections naturally. So, like if we're designing at 15 miles an hour, typically bicyclists actually stop pedaling or slow their pedaling approaching an
Mhm.
intersection, sort of expecting that there might be a conflict. So, that was sort of baked into those considerations. But in terms of like a person's ability to turn their head, that's sort of fundamentally baked into protected intersection design as a whole. And I don't think we included this graphic in the AASHTO bike guide, but if you look in the MassDOT separated bike lane guide, there was a good illustration in there showing if a bicyclist and a motor vehicle are placed in the same place in a conventional intersection, so a conventional bike lane, as opposed to in a separated bike lane at a protected intersection, then that simply by having that separation between the users actually means that the bicyclist becomes more visible and the conflict is more aligned um, with the driver's windshield as opposed to having to look in their mirror to see the conflict. So it sort of naturally creates those sight lines through the design recommendation.
Okay, great. So yeah, if you missed that, the MassDOT separated bike lane guide might be another good place to look. I'll see if I can drop a link in at some point
And
to
that
that. So
that's also where that 6 to 16 foot offset at the protected intersection sort of derives from. That
okay,
if it's narrower than that, which the bike guide does allow, then it is functioning a little more like a conventional bike lane. Whereas if you do that 6 to 16 and a half, the motorist would see the bicyclist in front of the vehicle rather
okay,
than at their quarter panel.
okay, got it. There were a few questions, Jeremy, about a figure, and I'm gonna say the number of it right now, and I don't know that we have time to like pull it up or anything. 7.9.5, and it was a situation where a motor vehicle is sort of entering from a side street and waiting to make a turn, moving across this bicycle facility, stopping for the pedestrian, then kind of moving into that bicycle path while kind of waiting to turn left or right. And there were some questions about, well, if how dangerous is this if you're thinking about a motor vehicle kind of moving in and essentially potentially blocking the bike path if they suddenly don't have that gap and they have to wait a little longer. Could you speak to that a little bit and maybe what design options there might be for allowing for that to happen, but making it as safe as possible.
Yeah, we thought a lot about this and sort of the safety aspect as well as the practical implementation considerations, and that, looking at the way the laws are written for drivers, that principle of you're allowed to look for users. If there aren't any, you're allowed to inch forward to the
Right.
point where you have better lines of sight. We're sort of applying that same principle for pedestrians to a bicycle facility. And so as a practitioner, if you're going to be assessing these sightlines with that understanding, you should be thinking about what are the volumes of bicyclists, what are the frequency of this additional conflict occurring. And it might be a situation where you want to limit turns or consider other design treatments that would limit the amount of time that a motorist is going to be sitting at that location. And so, it will be much easier for a motorist to simply make a right turn and only have to accept a gap in one direction of travel. So you might be prohibiting the through movement so
Mm,
that the duration of time that that motor vehicle might be blocking a part of or all of the bike facility would be diminished. This is
I see.
also one of those trade-offs where a two-way facility might actually work a little better if you're relying on this type of um, partial blocking of the bike facility, because the motor vehicle is less likely to be blocking all of that facility. And so there's a little more maneuverability. But yeah, it really does come down to this issue of trade-offs that, yeah, we could provide one big sight triangle that allows a motor vehicle to look for bicyclists and motor vehicle traffic all at the same time. But trying to apply that in our most urbanized areas would mean stripping out all of the parking from those blocks, and it's just not going to
Right.
be politically feasible to do that.
I see. Yeah, great points. That helps clarify that a bit. Um, One clarifying point, I guess you mentioned peak hour volume in a couple of places, I think, as a one measure. Could you give a little refresher about how peak hour volume should be calculated, or how it is calculated? Is that there were some questions about, is this for like a whole year, looking at a whole year and where the peaks are, or is it peak periods during the day, over the week? Are there any specific guidance there on how to calculate that?
Yeah, it's really asking you to look for the peak hour that is likely to be experienced during the year. And so, yeah, for a shared use path, that is more likely to be in the summer than in the winter.
Mhm.
And for many shared use paths, that might be on a weekend as opposed to during the workday, sort of depending on what the use and purpose of that facility is. If it's mostly serving as a transportation purpose, maybe during the week it actually will have its highest volumes during that time. Whereas if it's both serving a transportation and a recreational purpose, the weekends might be that time. And so yeah, assessing that with counters, or if it's a proposed facility, looking to comparable trails or shared use paths in your community or within your bike network, looking at the density of housing or destinations within that area to generate what those anticipated volumes might be.
Yeah. Okay, great. This is a question that it came in a few times. I think we got into a little bit more in episode one, but it might be worth revisiting. More of sort of a planning level question, and that is there anything in the guide about that kind of establishes or helps folks figure out what they might expect in terms of increases in bicycling activity, given different types of facilities they may be putting on the ground? Higher comfort facilities may be attracting more riders than others, but are there metrics there that can be helpful in making those calculations or making those assumptions in the planning stages of a project?
I mean, we do discuss like things like assessing what the anticipated volumes are and some methodology on how to go about doing that. We're certainly not prescriptive in that nature, and it does kind of need to be assessed on a project by project basis. We also did stress that high comfort facilities do increase volumes, and when we increase volumes, we're also increasing safety, which then sort of has this feedback loop of safety in numbers. It's more safe and comfortable, so more people bike, and that
Mm,
improves safety more. So, we do see those steady increases, but it's also tied to the completeness of the bicycle network, and that I hear it from time to time of, oh, well, they built that bike lane over there, but I don't ever see anybody use it, but it doesn't connect to anything. So, it was constructed because there was an opportunity based on, it's the mill and overlay, it's our maintenance cycle, there's space to do it, we're going to add it. But in the short term, it has a little less value until we can build out that network. So it's all interrelated to a lot of different things. So it's kind of hard to give you a specific answer.
great. Yeah, that's okay. Hannah, did you have something to add there?
Yeah, I mean, I just wanted to add that it can be really hard to do that first piece when it doesn't connect. But you have to do the first piece because then when you go to do the second piece, if you didn't do the first piece, then the argument is, well, that doesn't connect either. And in particular for MnDOT, bridges are one of the areas where we can really struggle. There might not be an approaching facility coming at the bridge yet, but we know that's a 75-year investment. So sometimes we'll end up doing stuff on our bridges that, well, why is that there? With the hopes that in the next several generations, something will approach it. So
I see. Yeah, no, that makes a lot of sense. That's a good point. Um, let's jump back into the question. And I forgot to invite Hannah formally and Charlotte back to the Q&A, but jump in anytime, y'all.
Jeremy's had it so far. I was like, do I go to this
Yeah.
webinar and say nothing? Maybe.
Well, I wanted to jump to some separated bike lane discussion here. We got quite a few questions about those, you can imagine. Is there any discussion in the guide about whether to include barriers, and I'm guessing here we mean like maybe parking stops or something in the parking separated bike lane condition, or is it simply paint on the ground marking those parking spaces, or are we wanting to have some additional barrier there that the motor vehicle then wouldn't be able to park beyond? I'm reading into the question a bit, but anything like that in the guide?
It it discusses both as an option.
Okay.
I do bike through one project on my way to work that is just parking, no flex posts or parking stops or anything. And it does typically mean the vehicles are encroaching a little more into the painted buffer than they otherwise would. The guide also speaks to the fact that if you're not providing other vertical objects in that street buffer, that you have to look at parking turnover and parking occupancy, that if it's fully parked up during the day, but then at night there's nobody parked there, then it's not going to function as a protected bike lane anymore, a separated bike lane, because none of that vertical element is present anymore.
Mm-hmm.
But it does allow for the use of just parked cars while also allowing you to supplement for other vertical objects in the painted buffer.
I see. Yeah. On the keeping with this parking separated bike lanes, there were several questions and comments that came in about the risk of a dooring crash or bicyclist striking the open door of a vehicle, possibly in where the situation where the bicycle lane is traveling, between the sidewalk and the parked car. How was that risk? Certainly, that risk was, known and thought about when the guide was being developed. Kind of wondering how the design of those separated bike lanes that can account for the risk and maybe reduce the risk of a dooring related crash if your vertical element is essentially a parked car.
Yeah, I mean, the width of the buffer is sort of key in that decision. And so the bike guide does speak to the width of the buffer and how that relates to locations with parking and without, and sort of prioritizing some wider buffers where you're adjacent to on-street parking while allowing for, I think it's as low as maybe 2 feet. I'm
Hmm.
trying to remember, but in other situations you can go to narrower. So yes, it's certainly an important consideration, and particularly in a separated bike lane, because unlike a conventional bike lane where you at least have a place to escape to into the adjacent general purpose lane, in a separated bike lane, you would have nowhere to go if you were in conflict with the door. So the design needs to accommodate that continuous movement of the bicyclist, even if the doors are open.
Yeah, that makes a lot of sense. Another topic that we received a lot of questions about were separated bike lanes that may be on higher speed roads, higher speed being maybe generally defined. But I'm not sure if there's a specific threshold. FHWA has some a guidance report that came out not long ago with I think it was over 35 miles an hour. Thinking about what the vertical element should be in those cases as you increase speed, what should we be thinking about in terms of changes in the design, but also what treatment we select for that vertical element. Is there anything about that and like that in the guide in terms of selecting that element and maybe the pros and cons of different types in a higher speed setting?
Well, it's not prescriptive, but
Mhm.
it does speak to speed. And so sort of flipping the question, it talks about for lower speed roads that those are situations where things like planters, so long as they're frangible, and that there's a little more opportunity to install some features in lower speed roads, whereas in a higher speed road, the number of options we have available to us might be a little more limited. And so you're certainly still allowed to install flex posts, since they are designed to, if struck by a vehicle, um, to be able to fold and pop back up. But also this idea that additional width of your buffer may be appropriate in a higher speed environment, and that similarly the use of things like concrete barrier can be appropriate in some higher volume locations, while also recognizing some of the trade-offs and challenges associated with that, that if we're installing a full height concrete barrier, a Jersey style barrier, whatever you want to call it, that then they need to have impact attenuators on them. Typically, you need to stop them in advance of intersections and convert to something else because
Mhm.
of their height. A child bicyclist or a recumbent bicyclist wouldn't be visible. They'd be blocked by those concrete barriers. So it does speak to those things while also highlighting the challenges and design considerations.
Absolutely. I did just drop a link to the FHWA report on separated bike lanes on higher speed roadways if anyone's interested in diving more into that topic. There was some maybe some useful information there. I wanted to shift to another question about this question about intermediate versus street level versus sidewalk level bike lanes. So this person is asking, can we possibly discuss in more detail the benefits of designing and installing the intermediate bike lane versus those street level or sidewalk level bike lanes? This person says that they didn't personally see a benefit of the intermediate option compared to the sidewalk level, but maybe talking through just when and where, why those different options might be appropriate.
Yeah, the pedestrian accessibility piece is one of the foundational reasons why I would consider intermediate typically better than sidewalk level, particularly in our constrained environments where we are kind of putting a minimal sidewalk buffer, or in some cases, no sidewalk buffer at all. And if you're doing a sidewalk level design, then you're relying on some of these other tactile walking surface indicators to try to address the accessibility piece. Whereas just a simple sloping curb that's 2 or 3 inches in height, 6 inches wide, that is more reliably detectable to a person using a long white cane. So that's one big piece of it. But when you actually get into the design of some of these facilities, you start to find that a sidewalk level design presents a lot of challenges at intersections, at access to floating bus stops, or like there's a lot of grading challenges when you get down into the weeds of the design that
Mm.
can make it a little more difficult. And so one thing I found, if you're doing a sidewalk level design, if you're thinking about a pedestrian crossing that might run perpendicular to your separated bike lane, that oftentimes when you design the curb ramp for that to cross the street, the landing at the top of the curb ramp ends up being in the separated bike lane. Whereas if
Mm.
you do intermediate level design, you're going to ramp down a little to get to the intermediate level, but then you find that you can do a true pedestrian refuge median between the road and the edge of the bikeway. So even in sidewalk level designs, sometimes in order to get the grading to work, you end up transitioning on the approach to the intersection to either intermediate or street level, like the Jackson Street project in St. Paul, Minnesota. That was sidewalk level, but as you approach the intersections, it ends up dipping down because you otherwise can't get the grading to even work.
I see. Yeah. Very interesting. Thanks for handling that. I wanted to touch on some transit stop questions before we move to shared use paths for the last bit. There were a few questions about the transit stop slide you showed. It was 7.9.14 was the figure number. There was some questions about, I think it showed a mid-block transit stop, and there were some questions about whether far side transit stops were handled, and if so, like what would we need to be thinking through considerations for those far side stops?
Yeah, it's the same design considerations. Far side is typically preferable for transit stops, though, that's all contingent on transit routing and a number of other features. But just in terms of like through progression for transit, typically far side ends up reducing delay for transit. But
Mm.
functionally speaking, in terms of the design and layout and this idea of incorporating one of the crossings to the floating bus stop into the intersection design, all of that still holds true with the far side style
Okay,
design.
I see. When we get into trails and shared use paths, there were a few questions about the stop versus yield signage where the shared use path crosses the roadway, and sort of this idea that there's this continued use of these trail stop signs when a lot of state law may not necessarily agree, or there may be some inconsistencies there. Could you just speak to that decision to place those signs, the stop versus the yield, and what might we be thinking about as we design those, especially where there may be frequent roadway crossings, to have those. I was just in an area in the coast of North Carolina where it felt like just stop sign, you ride your bike for 20 feet and then you're stopping again. What are we thinking about there when we design those crossings to make them as safe as possible, but also allow for that more continuous flow of bicycle traffic if we can?
Yeah, it really comes down to the sight distance, that if you don't have a sight distance that accommodates yield operations, those are the situations where the more restrictive stop control is going to be necessary or appropriate. But as long as we have adequate lines of sight, transitioning that sort of more standardized approach to being yield style control can be considered. I'm trying to remember. I think there was a design running down the middle of a street of a shared use path in Baton Rouge that used yield signs, and I took a photo where you could see like 12 yield signs in a row, but
Hmm.
it sort of at least reinforces that that's 12 successive locations where you're not required to come to a full stop.
Sure. Yeah. Hannah, did you have something? Yeah.
Yeah, I was just gonna add in, so in chapter 5, and I know Jeremy touched on this a little bit, but the discussion in 5.9 about sort of how to make the decision about who has the right of way at a particular crossing location and what type of signing to do, I think is a really informative discussion. It's sort of sometimes it comes down to being sort of just a personal decision by your traffic engineer with respect to what type of signing they might feel comfortable with. But I think the conversation in that section of the guide is really helpful.
Great. Thanks for pointing that out. Yeah, hopefully we can refer back to that section for
Mm.
more detail there. There was a few questions I think about the use of either dashed or solid center lines on a shared use path. Jeremy, what does the guide say about this?
If I remember correctly, it aligns with the METCD that Centerline markings are not required. The dashing is appropriate to communicate that passing into the oncoming lane is appropriate, and that solid markings should be reserved for locations where passing would be problematic, such as approaching curves or through curves, and then approaching intersections where you kind of want to limit that passing and ensure that people are staying in their lane.
I see. Yeah, that's a great point. We also had a few questions about bicycle boulevards. This one kind of encapsulates a lot of the ones we received, and they ask if is there any information about low traffic neighborhoods and how these can create low traffic streets suitable for cycling on multiple roads rather than sort of a more linear bicycle boulevard approach. And it seems to me like this is maybe again more of a planning level question about looking at your network and determining where these routes should go. Sort of areas of low traffic where bicycling can be prioritized rather than maybe a one continuous corridor established as the bicycle boulevard.
Yeah, I mean, certainly if you have a community with lots of streets with low volumes, they're going to function as a low stress location. It's probably where people that bike are already biking today. Um, I think some of the benefit of the bicycle boulevard approach, or you could have multiple parallel bicycle boulevards, but perhaps not every single block, maybe, depending on the density of your network, is that by designating it as a bike boulevard, it's more likely to concentrate movements to that location. So again, the safety in numbers principle, that it's the corridor where motorists are going to expect more bicyclists to be present. Also in terms of just the overall bicycle network as a whole, and if the bike boulevard is serving as a connection from one road to another, sort of concentrating that to one location can also have benefit, because one of the other key elements of the bike boulevard is reinforcing that that is the signed route or the location where you should expect bicyclists to be. So like, yeah, I'm working on a project in Albuquerque, New Mexico right now where there are multiple intersecting streets. Quite a few of them have low volume, but one of them is on the bike plan as the bike boulevard. And so we're trying to prioritize the movement of people from this shared use path onto that boulevard. And so creating more intuitive connections to that location while still accommodating the connection to some of the other ones for the people that live on there, but really not going to be intended or used for more through bicycle traffic.
Okay. Um, this may be a clarifying question. It could be that we're covering this in part three, so let me know. How are raised intersections handled, if at all, in this guide, or should we punt that one?
I don't think it's in the other chapters. I mean, we do talk, I'm struggling to remember if we specifically address raised intersections, though it sort of aligns with what I was talking about in chapter 5 of those intersection design principles, and that raised crossings have a
Mhm.
benefit at side streets, and the same sort of foundational approach holds true at raised intersections, that that would be a vertical traffic calming element that's going to slow motor vehicles, and that'd be from all legs or all approaches
Right.
of the intersection, while also having some of those same similar challenges of ensuring that we're addressing pedestrian accessibility, et cetera.
I see. Okay. Thank you for that. And then finally, I don't think we actually covered this one in part one, but as you can imagine, a lot of questions about what about places with a lot of snow and ice and snow removal and snow plowing. That's a big question. It probably handled many different ways depending on the facility type, but I imagine that that was an acknowledgement in the guide, and we realized that snow removal is a big issue for a lot of places. How do you recommend folks with those concerns maybe approach some of the guide's contents? And I'm sure maybe Hannah can jump in coming from a place that sees a little bit of snow during the year.
We will talk a little bit about this in the next webinar, because there is
Okay.
a whole chapter around maintenance, but really that's talking more about thinking about what equipment we have and
Hmm.
whether based on the design of the facility, we need to purchase new equipment or smaller equipment, or sometimes that's the justification for sizing our facility a certain width because we're not going to purchase new equipment and we're going to have to repurpose or use the equipment that we already have available to us. So that certainly is a consideration. I did mention it and how that would relate to the design of things like mountable aprons. Roundabouts have certainly been constructed in cold weather climates, and we've shown time and again that it's not that difficult to plow the center mountable apron. But on all these corner islands, that's a similar approach, a unique consideration, and something we should be thinking about in terms of the curb profile that's not going to snag on the plow, and thinking about some of that snow deposit issues and how we can resolve that. So there are strategies for that. We don't go too in depth to it in the bike guide purely because it's a multi-jurisdictional design guide trying to cover the basics of design. But yeah, the maintenance chapter, we will speak to some of that.
Great. Excellent. We'll look forward to that. Hannah, any other snow tips
Yeah,
for us?
let's see, where do I start? You're asking a Minnesotan about snow in July, so I only have good things to say about it right now. I mean, I think having the right equipment is really what's key. MnDOT's been working with a couple of our local agencies to kind of find out what works for them, and it really comes down to the equipment investment. You can do a lot with a skid steer and a pickup truck, but if all you have is a shovel and a road plow, you have to kind of get that in between. And then I think the other thing that we're really seeing is funding for maintenance is really critical. Capital projects are exciting and shiny and new, but getting the funding for maintenance is one of the big issues for us there. The good thing about snow is that if you wait long enough, it will melt. So.
I've heard that. Yeah, that's great. Well, we could probably do a whole webinar on that topic in and of itself. We'll leave it there. Come back to it a little bit in part 3. We're out of time for Q&A. We're a minute over, so I apologize to everyone getting on to your next meetings. I did drop a link in the chat to our post-webinar questions. We're going to email that out too, so you didn't get it now, you'll get it later. But think about those deep dive topics. Start putting those into these surveys for us, because we want to know what should we be focusing attention on after the series? What are you still wondering about, still want to know about? We're going to try to handle as much as we can. A big thanks to Jeremy for taking us all the way through today, and for Charlotte and Hannah coming back and joining the discussion. We'll have everybody back in a little more than a month for part 3, the final episode in the series. Again, stay tuned for that follow-up email. You'll get all the archive page information, recordings, things like that. Thanks for joining us, and we hope to see you all next time.
Thank you.
Thanks, everyone.
Thanks, everyone.